Hello students, Jai Somnaran. I am Professor Urvish Mewada at Electrical Department, Sri Somnaran Institute of Technology, Gandhinagar. I am the subject matter of Power System 2 subject, which is in the 5th semester Electrical Engineering, and GTU subject code of this subject is 3150911. Students, currently we are discussing the practical session of Power System 2 subject, and we have discussed till today the total 4 experiments. The first experiment that we have discussed, the performance parameter of the short transmission line, means as we vary the power factor of the transmission system according to the variation of the power system, the voltage regulation of the power system will vary. Similarly, we check all the this parameter with all the transmission types. First, we was discussing the first chapter, first experiment, that was for the short transmission, and for the second practical we have discussed for the medium transmission, in which we have discussed in detail nominal T method, nominal pi method, and then after we have discussed for the short transmission, for the long transmission system in the third experiment, and then after we have discussed the ABCD parameter using MATLAB. Now this is our practical number 5, that is MATLAB program for the fault analysis of the synchronous machine. Students, in synchronous machine generally we have discussed different type of faults in the theory section. Now today we are going to discuss the actual value of the fault current for different cases, say for 3-phase symmetrical short circuit fault, for one line to earth fault, then for double line to earth fault, and for the line to line fault. So such faults frequently occur in the synchronous machine, so that we are going to study using MATLAB. So let us discuss how this can be done with using MATLAB, and that will be more clear to you how this will create the faults and what will be the magnitude of the fault current whenever such kind of fault occurs in the system. So let us discuss. Okay, so this is the program that I have prepared for the solution of the synchronous machine faults. So let us start with the program first that I have fitted in this MATLAB programming. So let us start with the first command, that is CLC. So CLC and clear all will clear all the previous fitted matters which we put for the solution. So let us start with the program. So display, so it will display with the welcome to the fault analysis of the synchronous machine. So this will be display first, and second one, that is MVA input. So the system will ask for the enter the MVA rating of the synchronous machine. So we need to fill the MVA rating of the synchronous machine, for which we need to find out the fault current for the different say states of the power system. Now the kV is equal to input, so it is asking for the kV rating of the synchronous generator. So after that the IB is equal to MVA into 1000 divided by square root of 3 into kV. So this is the formula which defines the value of the current. So let us discuss A is equal to, that is 0. minus 0.5 plus 0.866i. So this is the formula for A. So yes, first option that will be filled, that is enter the type of fault, line to ground fault, line to line fault, double line to ground fault, then 3-phase fault, and then after we need to put the option. So for that it will be indicate 1, 2, 3, 4, 5 different type of faults. So if you fill the number 1, then it will ask for the Z1 input, enter the positive sequence in PU. So we need to put the impedance of the positive sequence, then after Z2 is the input for the negative sequence impedance, and Z0 will be the enter the zero sequence impedance in PU. So yes, after that the IA1, that we have already discussed such kind of equations for the positive sequence, negative sequence, and zero sequence. So yes, IA1 is equal to 1 plus J0 divided by Z1 plus Z2 plus Z0. So where IA is equal to 3 into IA into 1. So this is the formula that we have filled for the calculation, where IF is equal to IB into EBS into IA. So where fault current is determined by this IB that we have formulated over here, and then after ABS that will be the IA depending upon the current IA. So yes, that will be print F, means that will be printed if the fault current will be solved by this equations. So the value of the fault current is will be printed on this. Then after else means if and else command is used over here. So if we select the option number 2, so option number 2 is over here. You can see that option number 1 is the type of fault is line to ground fault. Then suppose we connect the line to line fault, then it will go into the option number 2 and repeat the same steps, and then after it will indicate the actual value of the fault current. And then after if we have not use the option 2, then it will go into the option number 3, and then option number 3, that will be Z1 input is positive sequence impedance, negative sequence impedance, and we need to insert the zero sequence impedance. Then after the IF is equal to 3 into Z2 into 1 plus J0 divided by Z0 into Z1 plus Z0 into Z2 plus Z1 into Z2. So the fault current will be IB into ABS into IF. So whatever the value of IF will get put over here, and then after we will get the value of the fault current. And the else otherwise it is Z1 is equal to input, enter the positive sequence impedance in PU. So that will be printed, means that will be calculated over here. That will be IA is equal to 1 plus J0 divided by Z1, and IF will be IB into ABS into IA. So over here you can see that the IF is IB into ABS into IA, so that will print the actual value of the fault current for the third option. So this is the program that we feed over here, and now I am running this program. So over here I'm placing this run button, run. Now I will open this into the command window. So into the command window, as I explained, that it will indicate, first of all it will indicate welcome to the fault analysis of the synchronous machine. So this program is asking for the MVA rating of the synchronous generator. So let us feed the MVA rating of the synchronous generator, say 75 MVA. I am putting the value here, 75. Now this is asking for the kV rating of the synchronous generator. Now I'm just randomly putting the value 11.8 over here. So this is the kV rating. Now over here it is showing that line to ground fault, line to line fault, double line to ground fault, and three-phase fault. So yes, if we want to find out the line to line fault, then line to ground fault, then double line to ground fault, and three-phase fault, so we can select any of this. So I am selecting the first is the say three-phase fault, suppose. So I am putting over here, so three-phase fault. So it is asking for the, you can see that it is asking for the positive sequence impedance in PU. So I am just putting the positive sequence impedance over here, that is 2 into I. So this is how you can feel the positive sequence of this. So see, you can see that the generator MVA rating again appear, and whatever the result that we have indicated, that is 1834.79958, that is the value of the fault current. So I am feeding the data once again. I think I press enter 2 times. So yes, I am putting the value again, 75, then 11.8, then the option will appear and place 3-phase. So I am putting, now I am putting the inserting the value of the PU, means the positive sequence impedance in PU. So it is 2 into I. Now this is the value, this is 1834.79958. So this is the value of the fault current for the 3-phase symmetrical short circuit. Okay, so this program will be repeated. Suppose I put enter over here like this, and just a minute. So again, if we want to find out the other type of fold, say one line to earth fold, or we can say double line to earth fold, or line to line fold, then again this will appear. Now I am putting the data like as I previously inserted, so 75, 11.8. okay, so you can see that this window will appear. This pop-up will show that which type of fold you need to determine using this program. So secondly I am pressing the line to line fold. So this is the line to line fold. So enter the positive sequence impedance in PU for the line to line fold. So that is 2 point that I have inserted in the previous case. We are inserting same values. The current will be different according to the equation 2 into I. Okay, now the negative sequence that is 0.16 into I. So this is in PU also. So this is the value that is shown by this program using simulation, that is 2942.561205. So this is the actual value of the fold current when line to line fold occur, and where the MVA rating of the generator is 75, KVA rating is 11.8, and if the positive sequence impedance is in PU is 2 into I, and the negative sequence impedance is 0.16, then the generator will offer this much amount of fold current whenever the line to line fold occur in the system. So again I am clearing this command window, and again we are going to find out for the next type of fold, that is, so over here you can see that again this will appear that welcome to the fold analysis of the synchronous machine. So let us put the data again, feed the data again, that is 75 again, then the generator synchronous generator KVA rating, that is 11.8, and this pop-up will appear again. Now you can see that double line to ground fold, so I am placing this double line to ground fold. So yes, we can feed the positive sequence PU, that is 2 into, you can feed any random data if you want to find out this fold current for this synchronous machine. So now second is negative sequence is 0.16, so 0.16 into I. So enter the zero sequence, that is 0.08 into I. So you can have you will have this answer, that is actual value of the fold current for the double line to ground or double line to earth fold is 3574.284904. So this is the program which is helpful to find out the fold current value of the system whenever such kind of fold arise. Now let us discuss the last fold. Now again I am clearing this window, so you can write the CLC command over here, so this window will be clear. Now again I am running the program that I have fitted in this MATLAB program. So you can see that this is again appear that insert the MVA rating. So let us again insert the MVA rating, that is 75, then 11.8, then the type of fold means that the third type of fold, that is that we means for three phase fold we have calculated, line to line fold we have calculated, then double line to ground we have we have calculated. Now line to ground fold. So line to ground fold. So yes, for that the positive sequence that we have already fitted means we used in the previous case, so 2 into IPU, and the negative sequence, that is 0.16 into I, means it is also is in PU. So the zero sequence, that is 0.08 into I. So this is the data that we are feeding over here. So from that, the value of the fault current for say line to earth fault is say 4914.641744. so this is how we can solve the positive means the situation of the fault current for different type of faults, say for three-phase symmetrical short circuit fault, for symmetrical three-phase fault, then for one line to earth fault, or for double line to earth fault, or for line to line fault, using such algorithm for the MATLAB, using MATLAB programming. So this is what I have done in this experiment number 5, and if you have any doubt or query related to this topic, then we can solve your doubts and queries in our doubt solving session. Also feel free to call me to solve your doubt related to this topic or any of the topic which is relevant to the electrical engineering. So thank you very much, student. Thank you all. Jai Swaminarayan. The related document to this experiment I will send you into the Google Classroom link. So this is what I am done for this presentation. Thank you very much, student. Thank you all. Jai Swaminarayan.